Now that we have looked at positions and velocities, it's time to study the dynamics of a quadrotor. Once again, let's remind ourselves that we have two coordinate systems, one attached to the moving robot, and the other the inertial coordinate system. B1, B2, B3 constitute the set of unit vectors that describe the body fixed coordinate system, and likewise A1, A2, A3 describe the coordinate system that's fixed to the inertial frame. Recall that you have four rotors, each of which is independently actuated. R is the position vector of the center of mass, and we know expressions for the thrusts that the motors produce on the airframe. We also know the expressions for the reaction moments, and both of these are proportional to the square of the angular speeds of the rotors. We've seen how Euler angles are used to represent rotations. We will use the ZXY convention, the first rotation being about the z-axis through psi, the second one about the x-axis, and the third one about the y-axis. So the first axis is yaw, the second one is roll, the third one is pitch. Again, just to remind ourselves, this is the ZXY convention. The first rotation about the z-axis through psi, the second rotation about the x-axis through phi, this is the roll angle, and finally the pitch about the y-axis through theta. Of course, there are singularities. Singularities occur when the roll angle is equal to 0, which is phi equal to 0. And even when the angle phi is not equal to 0, you can have two sets of Euler angles for every rotation. Let's look at the external forces and moments that act on the airframe. We have four thrusts, F1, F2, and F3, and F4, and then four moments, M1, M2, and M3, and M4. The sum of the forces is obtained by adding up the thrust vectors and the gravity vector. The sum of the moments is obtained by adding up the reaction moments as well as the moments of the thrust forces. Again, these are vector computations. You have to add 3×1 vectors in each of these equations. To predict the net acceleration, we have to write down the equations of motion. These come from Newton and Euler, and they're called the Newton-Euler equations.